In 1994, Bill Gates purchased a single 500-year-old journal for nearly $31 million, a price tag now valued over $400 million. Within these pages, Da Vinci documented the principles of science, education, and technology half a millennium before they became standard for our modern world. While 16th-century warfare relied on static defenses, Da Vinci sketched a combat machine shaped like a turtle. This design featured cannons mounted along its entire circumference, allowing it to strike in any direction while protecting the crew inside. His work in aeronautics predicted the mechanics of lift long before the Wright brothers were born. He designed a spiral rotor, mapping out the exact physics that allow a modern helicopter to rise vertically into the air. The accuracy of his calculations remained untested for centuries. However, in the year 2000, a skydiver used a parachute built to Da Vinci's exact specifications, successfully descending 10,000 feet without modern safety backups. Perhaps his most improbable feat was this map of an Italian city. Without airplanes or satellites, he produced a perfect, geometric top-down view of the urban grid and winding river, a perspective impossible for humans to see for another 400 years. These weren't lucky guesses. Da Vinci operated through a specific cognitive framework that allowed him to observe the laws of nature and project their logical conclusions far into the future. Modern learning typically separates subjects like physics, biology, and art into distinct silos. Da Vinci's interconnected theory worked in the opposite direction. He viewed the world as a single system where every discipline informed the others. To master the mechanics of flight, he spent hours releasing birds from cages. He sketched their wings frame by frame, noting how the feathers adjusted to the wind to understand the engineering required for a human-made flying machine. This need for accuracy drove him to graveyards, where he performed illicit dissections of human corpses to see exactly how muscles and tendons were anchored to the bone. The resulting sketches, totaling 240 anatomical studies, detail the internal vascular and muscular systems with a precision that mirrors modern medical imaging. He applied this deep biological data back into his art. He spent 14 years on a single portrait, using brushes thinner than a human hair to recreate the subtle facial expressions he had mapped during his dissections. By refusing to recognize the boundaries between artist and scientist, Da Vinci discovered the underlying mechanics that govern how the universe functions. In his biography of Da Vinci, Walter Isaacson identifies a replicable three-step method the artist used to process information. Step 1 is hyper-physical observation. Da Vinci would write down every physical detail of a problem or object, forcing his mind to acknowledge the raw data before attempting to solve anything. Step 2 involves mapping reactions. He would observe a single change and then document the exact cause and effect it had on the surrounding elements, creating a mental map of how the entire system responded. The final step requires a complete break. Da Vinci often left projects for days at a time, allowing his subconscious to process the data in the background and identify flaws that weren't visible during active work. This process shows that his output wasn't the result of a sudden spark of genius, but a mechanical system of feeding the brain extreme detail and then stepping away to let the mind synthesize it. Da Vinci noted that the human mind naturally resists this level of effort. The brain prefers comfort and often tries to avoid the rigorous work of true observation by settling for the easiest explanation. To push through these mental roadblocks, he used a sense of humor to mock difficult situations. By trading obstacles with levity, he maintained the courage needed to continue his experiments when others would have given up. We see the value of this cross-pollination in modern innovation. Just as a bear riding a unicycle is more interesting than either on its own, breakthroughs happen when someone combines two unrelated industries, like merging data science with architecture to find solutions specialists miss. The world's largest leaps forward occur at the intersection, where rigid professional and academic boundaries are ignored. Analyzing Da Vinci's life reveals that his results came from a source other than raw talent or formal schooling. His primary engine was an obsessive curiosity, a physical itch to know why the sky is blue or how a bird remains in the air. He would research and experiment until the mechanism became clear. He believed that nature never breaks its own laws. This means the answers to every complex problem are already present in our environment, provided we are willing to look with enough intensity to see them. When you stop compartmentalizing your life and let your curiosity span across different disciplines, you begin to see the underlying connections that others overlook.